Hi everyone. So in today's lecture, we have done two examples, and however, in one of the examples, we haven't finished writing the solution. So I'm going to redo the solution for this example. So if you look at the example, we have an elliptical gate that covers the end of a pipe. So where is the gate? This is the gate. The gate is of plane surface. So the gate covers the end of a pipe. So we have two shapes here. One is the gate shape, which is, you draw this in 3D and see the ellipse. Alright. So in ellipse, we have this center. Okay, from the center to the top is, I put it as A. From the center to the side, put it as B. Right. So this B has to follow the diameter of the pipe, because the ellipse gate or the elliptical gate is used to cover the end of the pipe. So it must follow the diameter of, or the radius or the diameter of the pipe. So the diameter is 4 meters. So radius is 2 meters. So this B follow the radius of the pipe, which is 2 meters. And then A cannot follow the diameter because this is ellipse. So A is 5, which is the whole height is 5. So A is half of 5. So A is 5 divided by 2, it's 2.5 meters. Alright. So remember, when you want to solve this kind of problem, the first step is to draw the free body diagram. So in this free body diagram, you have to draw or you have to state all the forces that act on the gate. So the gate has hydrostatic force exerted on it. So where is hydrostatic force? It's slightly below the centroid. So let's say this is the centroid. The hydrostatic force must act slightly below. Okay, through CP. CP is center of pressure. So it is somewhere below this centroid through CP. And then on the diagram itself, it has external force F, where we need to find this F. This external force is used to open the gate. This hydrostatic force is used to close the gate. So this F, external force, is needed to open the gate. Alright. Other information that you want to know later is the distance or the vertical distance from the water surface to the centroid, which I call it as HC. So this HC is needed to find FH. And other things that you want to know later to solve this problem is YCP, where YCP is the inclined distance or the distance from the centroid to the line of action of the hydrostatic force. So another thing that you want to know is YCP. YCP is basically the inclined distance from the water surface to the centroid. So I call it as YCP. Another thing that you want to know is Y hinge. I call it Y hinge because I want to know the distance from the line of action of the force to the hinge. I simply call it Y hinge. You can call it anything you want. I call it Y hinge because it is the distance from the force to the hinge. So these are the things that you need to know or you need to find later. And second step is to find the hydrostatic force, the magnitude. So this hydrostatic force magnitude, so we have Hc. The first one is Hc. So Hc if you look at the diagram, the HC is 8 meters plus. So another distance from here to the centroid is 4 meters divided by 2. So 8 meters plus 2 meters. 10 meters. And second step is to find area. So area of ellipse is given by pi AB. So pi times A is 2.5, B is 2. So you will get 5 pi meter squared. And last but not least, for this magnitude is to find the FH by using gamma or rho G. HCA, gamma of water is 9810 Newton per meter cube. HC is 10. A is 5 pi meter squared. So you should get 9810 times 10 times 5 is 490,500 pi Newton. So force is in Newton. Then this step is done. Another step is to find Y hinge. Why we need Y hinge? Because later we want to do the summation of moment. So to find Y hinge, the first step that you need to do is to find YC. So YC, if you look at this diagram, you can try to imagine that you have a triangle. So this triangle, it consists of HC, YC. So it is inclined at a certain angle here. And at the same time, you also have this small triangle here. I use different color here. So this small triangle is basically here at the bottom here. So if I draw it separately, this should be 2 meters and this should be 2.5 meters, which is half of 5. 2 meters is half of 4. So therefore, you can use fraction. If you use fraction, another thing is that it also is at this angle. So you use fraction. AC divided by YC is basically the same as 2 divided by 2.5 meters. So therefore, YC is basically HC times 2.5. So HC is 10 times 2.5 divided by 2. So you should be able to get the answer is 12.5 meters. Right? So 12.5 meters. The next step is to find YCP. So basically, YCP is IXC divided by YCA. So IXC, if you look at the our slide that I provided, there is a correction because the given formula is by A power of 4 times B divided by 4. However, this formula is wrong because at the end you should get meter power of 4. So if you check with other textbook, it should be by A power of 3. Okay? It's not that the textbook is wrong, it's just that the slide is wrong. Okay, you can use power of 3 here. Sorry, we'll try to, okay. Okay, sorry. Okay, it's power of 3 here. Yeah, okay. So, A is 2.5, B is 2, and you divide by 4, you times with YC, and you times with area. Area is 5 pi. Pi is cancelled. So 2.5 power of 3 times 2 divided by 4 divided by 12.5 divided by 5. So you get 0.125 meters. Then find Y hinge. So basically Y hinge is YCP plus half of 5, which is YCP plus half of 5 is 2.5. So it's 2.625 meters. Okay. Then only you find F by using summation of moment. So when the system is in equilibrium, the summation of moment is equal to 0. So I assume positive counterclockwise. Therefore, F hinge times Y hinge, which is the perpendicular distance, minus F times 5 equal to 0. Therefore, force is, therefore, F is F hinge times Y hinge divided by 5. So F hinge is 490,500 pi Newton times Y hinge. Y hinge is 0.625 meters divided by 5. So you should get the answer as 490,500 times with pi times 2.625 divided by 5. It's quite long here. 808,999.3782, right? So you can just simplify it to 809 kilo Newton. Alright? So that should be the answer. So I hope you understand. If you have any question, you can ask me. Thank you.